Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about to measure the flow in open channels. Different shaped weirs are used that cause a difference in the height of the liquid in the channel between the area before the weir and its lowest point. The weir should be at right angles to the direction of the flow, and the upstream channel should be straight at least 10 times the width. The differential height is measured at a point far enough upstream so that the slope of the water surface does not influence. This is the empirical formula for the flow, where it is proportional to the difference in height. The most used types of weirs are the rectangular with lateral concentration. This type is the simplest, cheapest, and easiest to build, suitable for measurements of flows from 0 to 60 cubic meters per hour to 0 to 2000 cubic meters per hour, this being the measurement formula that is usually used. If there is no discharge mantle concentration, the value 0.2H is replaced by 0.1H. Triangular or V consists of a plate with a V-shaped cut directed downwards and with each side inclined with respect to the vertical. Its field of measurement is wider than the other types of weirs, despite being the same size. It can measure between the range of 0 to 30 cubic meters per hour to 0 to 2,300 cubic meters per hour, this being its empirical formula, Cipolleti or trapezoidal with the groove in the shape of an inverted trapezoid. The slope of the sides of the trapezoid corrects the lateral contractions of the water mantle, so the flow is proportional to the height of the crest. It has the same field of measurement as the rectangular weir, and this is its empirical formula, Parshall or Venturi weir. This is used when liquids transport an excess of solids or sediments, when the pressure head is insufficient, or when it is not possible to build a straight section of sufficient length. It can be used for flow rates above 0 to 30 cubic meters per hour. The shape of this weir is similar to that of the Venturi tube. It consists of vertical walls and with the sloping floor at the choke. Here, the fluid discharge can be presented in two ways: free flow and submerged flow. Free flow when water elevation after throttling is low enough to prevent the discharging water from flowing backward and not following the profile of the partial element. And it is obtained when the ratio of the crest height in the flat part and in the final part of the element referred to the flat level HU over HD is less than 0.6 for a throat element up to 230 mm and less than 0.7 for throat widths greater than 300 mm. Submerged flow occurs when the water is too high after throttling and backs up. Head ratios greater than those of the free flow give rise to the submerged flows, in which the flow is a function of HU and HD, while in the free flow condition the flow is only a function of HU, this being the empirical equation of the partial weir. Turbine meters consist of a rotor that rotates as the fluid passes with a speed directly proportional to the flow rate. The pressure difference due to the change in area between the rotor and the rear cone exerts an equal or opposite force, and this makes the rotor hydromechanically balanced and able to rotate without having to use thrust bearings that can cause friction. There are two types of converters to capture the turbine speed: reluctance and inductive. In reluctance ones, there is a magnetic field through which the turbine blades pass individually. As each blade passes, the reluctance of magnetic field varies, and this variation changes the flux, inducing an alternating current in the pickup coil. In the inductive, the rotor carries a permanent magnet, and the generated magnetic field induces an alternating current in the external pickup coil. In both cases, the frequency generated by the rotor is proportional to the flow, being in the order of 250 to 1200 cycles per second for the maximum flow. The turbine is limited by the viscosity of the fluid, due to the change in the velocity of the liquid profile to the pipe when it increases. In the walls, the fluid moves slower than in the center, which causes that the tips of the blades cannot rotate at a higher speed. In general, in fluids greater than 3 to 5 centistokes, the measuring range of the instrument is reduced. The accuracy is very high, of the order of plus minus 0.3%. Maximum precision is achieved with a laminar regime by installing the instrument at a minimum of 15 diameters of straight pipe upstream and 6 diameters downstream. The measuring range goes up to the 15:1 ratio between the maximum and minimum flow and has a linear scale. The meter should be always filled with liquid, as the shock of the fluid at high speed at start-up could damage it. A filter should be used at the inlet of the instrument, as even the smallest particle can wear down the turbine blades and affect their accuracy. In gas measurements, a cartridge filter should always be installed upstream with a filtration degree of at least 3 to 5 microns, or that recommended by the manufacturer. The turbine meters can work with flow rates 20% higher than the stipulated maximum flow without causing damage. However, the life of the bearings will decrease. And well, this will be all for today's video. Don't forget to give me a like and subscribe. I upload videos every Wednesday in Spanish and every Friday in English. Adios! 100? 2000. No. And the and the upstream challenge. And the upstream. Dios del cielo. And the upstream. This where. ¡Qué Dios del universo!